Okay. So till question number 10, just we have to find second order derivative. Now here we have given y is equal to 5 cos x minus 3 and prove that d2y by dx square plus y is equal to 0. So this we have to prove. What? d2y by dx square, we have to prove d2y by dx square plus y is equal to 0. For that we have to differentiate two times first. So differentiate with respect to x, we get dy by dx is equal to differential of cos is minus sin x and differential of 3 is 0. Okay. Then again differentiate with respect to x, we get d2y by dx square is equal to minus, oh sorry, forgot to write here sin x. So minus 3 cos x. Differential of sin x is cos x. Then again differentiate with respect to x. So minus 5 differential of sin x is cos x and differential of cos x is minus sin x. That minus and minus will become plus. So we get plus 3 sin x. And in these questions actually you are getting y again. So that means this term in the second order derivative you have to replace by y. So if you will write this d2y by dx square is equal to, you can take the common minus. You take minus common, so it will become plus 5 cos x plus 3 sin x. And this is your first equation. When you use first equation using first equation, so this whole term is replaced by y. So we get d2y by dx square is equal to minus y, or you can bring y left hand side. So d2y by dx square plus y is equal to 0. That is 2. Okay. So here we have given in 12th question y is equal to cos inverse x. If we start directly in this question by this point differentiating both sides with respect to x, then it will be, that means you will get a very complicated result. So here what you have to do, so it is easy to take cos this side, so this will become cos y is equal to x. Okay, that means we have x is equal to cos y. So instead of finding dy by dx, we are finding dx by dy. We can find dy by dx also and dx by dy and then taking reciprocal. So with respect to y, now differentiate with respect to y and then taking reciprocal. This will become easier. So differentiate with respect to y. So dx by dy, because right side is the function of y, so dx by dy is equal to d by dy of cos y, and differential of cos y is dx dy is equal to minus sin y. Okay, now taking reciprocal because we need dx by dy. So now taking reciprocal. So it will become again dy by dx is equal to minus 1 by sin y. And this sin y we can take it in the numerator. So that means we got dy by dx is equal to minus cosec y. Now again we have to differentiate to find. Now you can see that we got the first derivative also in terms of y. We differentiate again, then again we should get with respect to dy by dx, one more will come, and then that dy by dx will be replaced by 1 by sin y. So now again differentiating with respect to x, again differentiate with respect to x. So we get d2y by dx square. When you are differentiating with respect to x, so first differential, write the differential of cosec y and then dy by dx, differential of y with respect to x. So cosec, differential of cosec y is equal to minus of cosec y cot y, and differential of y is dy by dx. And this is our equation number 1. So dy by dx is replaced from this equation. We get the answer in terms of y only. So now using equation number 1, we get d2y by dx square is equal to minus minus plus cosec y into cot y multiplied with dy by dx. Dy by dx is minus cosec y, and this will become minus cosec square y minus cot y into cosec square y. So we got this is only in terms of y only, fy. Okay. Now we have given y is equal to 3 cos log x plus 4 sin log x, and we have to show x2 y2 plus x y1 plus y is equal to 0. X2 means second order derivative. As I told you, second order, first order derivative can be represented by y1, y dash. So y1, either we write y1 or we write dy by dx. This is the same thing. Y dash also dy by dx. And second order derivative we can write y2. Y2 is equal to d2y by dx square. Similarly, we can also use y double dash. Y double dash is also the second order derivative. So d2y by dx square. We have a fifth second order derivative. So we have, that means we have to prove x square d2y by dx square, x square d2y by dx square plus x dy by dx plus y is equal to 0. So we will use y1, y2 for first order, second order derivative. Okay. So differentiate with respect to x. Differentiate with respect to x. So we get dy by dx is equal to, the outermost is cos. So differential of cos is minus sine, then differential of log x, that is 1 by x, plus similarly here the outermost function is sine, differential of sine is cos into differential of log x is 1 by x. This is our first order derivative. This is our first order derivative. We can write y1 is equal to minus 3 sine log x plus 4 cos log x divided by x. Now, do not try to differentiate again from this part, from this equation. We have to take this x left hand side, take it on the left hand side, then it will become x y1. Directly we will get this equation actually. There are two ways, find d2 over dx, d over dx in substituting, so that becomes difficult. So we will take x on left side, and this is as it is, right, minus 3 sine log x plus 4 cos log x. And now differentiate with respect to x. So again, differentiate with respect to x. That means I'll write here first to make you understood x d by dx of x into y 1, and here d by dx will go inside. So minus 3 we have to differentiate d by dx of sine of log x plus 4 constant d by dx of cos of log x. Okay, and we have to prove this. This we have to prove. Now, first function, second function. We have to use left side. First function, second function. Hmm. So as I told you, y1 is the first order derivative dy by dx. When you differentiating y1, that means dy1 by d by dx of dy1, it will become d2y by dx square. That means it will become y2. y1 when you differentiate, it will become y2. Hmm. So directly we can write here first function as it is x, as it is x, as it is, then differential of y1, that is y2, plus leaving y1 and differential of x is 1. Then right hand side minus 3 sine, differential of sine is cos log x into differential of log x is 1 by x. Here minus 4, differential of cos is minus sine log x into 1 by x. So we can write like, so this x again taking LCM, and this x we can multiply left hand side. So we get x square y2 plus x y1, that we have to bring up, is equal to this one, minus 3 cos x minus 4 sine log x, minus 3 cos log x minus 4 sine log x, and from this you can take out minus common. So we have 3 cos log x plus 4 sine log x, 4 sine log x, and this whole term is y, that is our equation number 1. can say this is equation number 1. So using first equation, we get x square y2 plus x y1 is equal to minus y. And this you can bring left side. So we got the result x square y2 plus x y1 plus y is equal to 0. And prove. Okay. So this type of question, if you will start doing directly without multiplying this x on left side, then it will become very difficult. Okay. Here we have given e to the power y. E to the power y. What is given us? E to the power y is equal to x plus 1 is equal to 1. And we have to prove this. This is second order derivative and this is the square of the first order derivative. Correct? So we get from this we can write e raised to power y is equal to 1 by x plus 1. And now differentiating with respect to x. With respect to x now. Differentiate with respect to x. So this is the function of y, so it will differentiate, but y will also differentiate it with respect to x, so dy by dx. And here 1 upon x plus 1, when you differentiate it, it will become x plus 1 raised to power minus 1, and its differential will be x plus 1 raised to power minus 1 minus 1 minus 2, so minus 1 upon x plus 1 whole square. This will be the differential of this. I have done directly. So this will become minus 1 by x plus 1 whole square. Okay. Now what we will do, we will substitute, we will bring this e to the power x here, and using this, then the right hand side will be totally converted into x, function of x. So this can be written as dy by dx is equal to minus 1 by x plus 1 whole square into 1 by e to the power y. And this value e to the power y, using equation number 1, using 1, we get dy by dx is equal to minus 1 by x plus 1 whole square. 1 upon e to the power y is equal to x plus 1. Reciprocal of that is x plus 1. So 1x plus 1 will cancel. We get minus 1 upon x plus 1. X plus 1. This is our first derivative. Now find again second derivative. So differentiate with respect to x. Again differentiate with respect to x. We get second order derivative d2y by dx square. This is first order derivative, equation number 2 you can say. And d2y by dx is equal to, I told you that this minus and minus will become plus, and this differential will be 1 upon x plus 1 the whole square. And that means this proof you can write d2y by dx square. This can be written as minus 1 upon x plus 1 the whole square. And why? Because this is dy by dx, and we can use the first equation, second, sorry. Then using the second one, this is replaced by, so we get d2y by dx square is equals to dy by dx whole square. and prove this one. Now we have given y is equal to tan inverse x to the whole square, and we have to prove this one. So here also don't start doing first, second direct. We have to multiply like we have done in previous question. So first differentiate with respect to x. So on differentiating with respect to x, we get differentiate dy over dx is equal to the outermost is power 2. X to the power 2 is the outermost function whose differential is 2x. So its differential will be 2 tan inverse x. And then differential of tan inverse x is equal to what? 1 upon 1 plus x square. Now, as I told you, this is first derivative we can replace by y1, and this 1 plus x square you can multiply left side. First 1 plus x square multiply left side is equal to 2 tan inverse x. Now differentiate. So again differentiating with respect to x. At this point you should remember for these type of questions. Differentiate with respect to x. If x or x plus 1, x plus 1 square, x square plus 1, something is coming in the denominator, you should multiply and then differentiate with respect to x. Now this is our first function and this is our second function. The first function as it is, first function 1 plus x square as it is, differential of y1 is y2 plus, now leaving y1, differential of 1 plus x square, differential of 1 plus x square is 2x. Okay, and again 2 differential of tan inverse x is again 1 plus 1 upon 1 plus x square, 1 upon 1 plus x square, and this 2 we have to bring left hand side 2. Now again this will be multiplied, we get the result. So 1 plus x square, when you bring left side, it will multiply with 1 plus x square, so it will become 1 plus x square whole square into y2 plus 2 into x, 2x into this x square plus 1 or 1 plus x square, same thing, into y1 is equal to 2. That means we got x square plus 1 whole square y2 plus 2x x square plus 1 into y1 is equal to 2 and 2. So, okay, so these are the extra questions from question number 1, second order derivative. Second is the first order derivative only. So, this is second order derivative, second order derivative, second order derivative, second order derivative, ये first order derivative, and this is also second order derivative. y2, this is minus 2. So try these questions. So next time, next week, we will start mean value theorem. We are not starting next class now.